Dear young friends, this is Kamal Sarma. Today I will be discussing about bending moment and shear force diagram again with trapezoidal and triangular load. Okay, so in my last class I told you about that I will be discussing the triangular and trapezoidal load that comes into picture when you design a building. Okay, that means if you have a slab like this, I am drawing the plan of the slab. If it is a two-way slab means if it is length, if it is breadth, L over B is less than 2, then it is two-way slab. If it is greater than 2, it is one-way slab. The characteristics of two-way and one-way is that in two-way slab, the part of the load, if there is a beam there and there is a beam there under that slab, part of the load will go to this beam, part of the load, if you draw 45-degree angle, part of the load will go there, and load is distributed to this beam, this beam, this beam, and this beam. This is what happens. So this is called tributary area. Okay, so dead load is transferred to this like this, load from the slab. So you see this is a triangle, right? This beam will subject to the triangular load. If you consider that this is the maximum intensity, the whole thing will be like this. If you have a beam, this will be like this, triangular. The other side, here, this beam will have trapezoidal load. That means part of them is linear, then constant, then again linear, trapezoidal. You see, this load is gradually varying, going upward. Okay, and this part it is constant. That means it is uniform. So this from here to here, it is uniformly distributed load. You can say it is uniformly distributed, and this part is triangular. It's just like a triangle. Here intensity is less, here intensity is little more, here more, then here is the maximum. That is the characteristics of triangular load. Here your intensity is less, is going up, 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 and here is the maximum. Suppose if you give a W there, W is the load maximum intensity at a midpoint. Say if it is say now we consider this is the length L of this beam. So if it is L over 2, you have W is the maximum intensity. So at a distance x from here, at a distance x from here to here, the x distance, what is the intensity here? If you consider is W dash, the W prime, you can call W prime equal to what? So you can, from similar angle triangle condition, so W over x, W prime over x equal to W over L over 2. So W prime equal to your W x, this is the value. So the W prime, whatever it is, here is a function of x. X is a distance from the left hand support. Okay, so that means If you find out the reaction there, I will tell you how to, I will solve a problem, then everything will be clear. If it is a R, what is the shear force here? Minus, you have to find out what is the total force coming there. You have to find out the area of this triangle. Area of the triangle is how much? This delta equal to half of base is your x. Then here we found out it is 2wx over L. These two to cancel, wx over L, right? And this x will make it square. That means wx square over L. So the shear force at this point, total unbalanced force, that is the meaning of shear force, total unbalanced force, transverse force. So that is equal to wx square over L. That is the situation. But now we see, you have a constant value, you have a R value, reaction, which you find out. A reaction is increasing at a parabolic rate. It is an equation of a parabola, square, x square, you know. Equation of a parabola, y is equal to mx square over c plus c, something like that, function of x square. It's x square, function of x square. So that means the shear force is declining in a parabolic way. Now we'll solve a problem now. I'm telling you the basic fundamental thing. First of all, the triangular load comes, if you consider a building where it carries a slab. This is the plan of the slab. It is a two-way slab. Here it is a tributary area. Triangular, this part tributary area is trapezoidal. So this triangular part is there like this, and trapezoidal is like this. First of all, we will be finding out the bending moment and shear force diagram for a triangular part. Then we will find out what should be the value for, or shear force and bending moment diagram value for a trapezoidal load. And that is the end of our lecture. So let us take some numerical problem. Okay, now this is your beam. For simplicity, we consider it is a simple beam or simply supported beam with one end is roller support, other end is pin supported. Okay, then we have a triangular load, maximum at the middle. Then here is the other end. Assume this is, you consider it is 10 meter or 10 feet. Either way, unit is different, but they are not same. As I told you earlier, the 1 meter equal to 3 feet 3.4 inches. That is the conversion. They are not same, but I am considering it same number with different unit. That doesn't mean they are equal. Okay, this is for the American system, feet, pound, and for the international system, SI unit, it is meter, Newton, right? So now it is here we consider the maximum is, say, again it is 10. You can consider kilonewton per meter at the maximum. This intensity at the midpoint. It may be decreased this way, decreased this way, or it is pound. You can say kip per feet. Kip means kilo pound. Unit is different, but number is same. Now, what is the reaction? Look at the reaction. Kilonewton or per meter or kip per meter. This is the intensity. Okay, not a concentrated load. If it is a concentrated load, it stays there only, then it will be kilonewton. But it is a intensity of the load here. Here it will be reducing. There also it is going reducing. Here it is 0 and 0. Now, what is the reaction here? This is only the vertical force. There is no horizontal reaction. Okay, so this vertical reaction will be, what is that? Total load is symmetric. So total load you divide by 2, half will go here, half will go there. So total load is how much? This is the, find out the area of the triangle. Half. Base is your 10th. Altitude is your 10th. So 100 divided by 2 is 50. So here it is 50. Here it is 50. Unit is same. If you consider kilonewton, this kilonewton. If you consider it is kip, it is kip. It is a kilonewton or kip. The kilonewton or kip. They are not same. They are different. The conversion is different because 10 kilonewton equal to your 2.25 kip. That is the conversion. Okay. Now, let us find out the reaction. 50. You already calculated the reaction 50 and 50. So, what is the shear force? So, here it is 50. It is the shear force diagram. You have to draw it like this. 50. What is your convention? Left. If left is upward, it is positive, and left is, if you go from left to right, if you calculate the value this way, so downward is negative, and if you come from this side, your downward is positive, upward is negative. So this is negative, this is positive. If you come from this way, that is the convention I told you long time back. Okay, and the upward force will be negative, downward force is positive. Here upward is negative, downward upward positive, downward negative. Now this is, you are calculating the value from left to right. 50, this is 50 here. Now what is the value for 1 meter, say, or 2 meters? Say consider the 2 meter. What is the value at 2 meter? Say somewhere here. The value is, shear force is this force. So this load will be coming down, this part. So definition of shear force is net unbalanced force at a particular section. This is net unbalanced transverse force. Okay, so this area of this is, what is the value of this one? You can calculate that. I told you earlier, but you can calculate. It is from here to here, distance is 5. So this is, if it is 10, If you consider W equal to 10 multiplied by 2, 2 is the distance, divided by 5, this distance. From similar triangle condition, this is one similar, this is one triangle, this is another triangle. So it is actually, I am calculating like this, W divided by X equal to capital W. I am considered the maximum at the middle, it is 5. This is actually your 10, this is actually your 2. So 20 divided by, okay, 20 divided by 5 is 4. So this is 4. So it is this value there, the value there is 50 minus 4, 46. So it is declining because I told you one thing, when the load is linear, the shear force is parabolic because we calculate the reaction, calculate the equation. So it is going like this, parabolic way declining. But the rate of declination is rapid when you go further because the load is increasing every inches or every centimeter to the right. So and also the maximum, everything will be 0 here. The shear force will be 0 here. Why? Because if you find out, this is the total reaction is 50, right? How we get the 50? Half of this area. This 50 and this total load of this triangle will neutral each other. So it will be 0 here. So our shear force will be like this. In other way, it going up and like this. The rate of intensity of decreasing, initially it is little flat, then going sharp. Because intensity is getting more and more to the right here. So it is like this. It is little bit flat at this point, sharply going down and come like this. This is a parabolic. This is positive, this is negative. You can prove it. If you have a distance at 4, 4, what is the shear force there? The 4 divided by, what is? W by 4, then 10 divided by 5. If you take out, it is W equal to 40 by 5, 8. See, so you are subtracting 8 from 50, right? At this point, it will be, at this point, it is W by 5, 10 over 5, so W is 10. So it is 0 there. 10 minus 10 is 0. 10 minus 4 is 8. 10 minus 2 is somewhere here. So it is initially, it is flat like this and coming sharp, going to the midpoint as 0 and going similar pattern going there because it is symmetric. Okay. Now, how the bending moment will look like? The bending moment without doing anything, you know from your experiences earlier, where the shear force is 0, where shear force is 0 or change is sign from positive to negative, at that point the bending moment is maximum. It is always true where the shear force changes its sign, except in certain case in support for negative moment. This is not there. But most of the time from positive moment or somewhere not at the support, some other point, when the shear force changes its sign, the bending moment is maximum. If we consider a continuous beam, okay, here it will be like this. Bending moment, the negative moment, but shear force will be something like this, going there, coming out, coming there, then it is coming down here. I cannot say, depending on the load. Here also some shear force, here also shear force is max, here shear force is maximum at the support here because there is a reaction there. Here is a shear force. So it is not necessarily it is for continuous. I cannot give you the value unless I solve a problem. So it is true when you have in between the beam, when it changes its sign from positive to negative, there the moment is maximum. Got my point? Now, when you have a bending moment diagram is maximum there, and when you have this is parabolic, shear force is parabolic, this is shear force diagram. Your bending moment is cubic. It will be cubic like this. More sharp, maximum moment. You can calculate the maximum moment. How much the maximum moment here? This is 50. Maximum moment is, find out. What is the reaction? 50. What is the area of this triangle? We calculate that. That is your half. Base is 5 into 10. 25, right? What is the load? Total load? It is half base into altitude. That is the total load. This is 25, correct? Half base is 5 and 10. 50 divided by 25. So what is the moment? Where it will be acting? It will be acting at this point. One third from this end. 1/3. Here. Distance is 1/3. The triangle CG lies at a 1/3. If you have a triangle, the center of gravity will be somewhere here. From the distance here is 1/3. 1/3 of this. 1/3 of this length, somewhere here, 1/3. There. So 1/3 there, it is going down. So this force will be acting at a 1/3 of 5, right? So this distance is 5/3. If this is 5, so 5/3 is the distance. It is acting, this load is acting at this point. What is the moment at this point now? Bending moment? 50 times 5, 50 times 5 minus, because this moment, this is clockwise, positive, clockwise, positive, if you are considering from the left, anti-clockwise, negative. So this is clockwise, is 50 minus 5, 50 times 5 minus, What is the load? 25 times 5 upon 3. Okay, this value is how much is the value? 50 times 5 equal to 250 minus 25 times 5 divided by 3, 41 point, again 25 times 5, 125 divided by 3, 41.67. So it is 250 minus 41.67. This is 208.33. Though this value is 208.33. Unit is kilonewton meter or keep fit, depending on which unit you are using. So this is the maximum. The rest of the things you can calculate, but it's up to you. You don't need to. But at any point, what is the bending moment? You can find out the regular equation. This force multiplied by distance, part of the force, whatever is there, find out the total force, find out the CG distance at the 1/3, then that is the, you multiply, that is the moment at any point. This is how you calculate. That is the, in a triangle, the center of gravity or CZ lies at the 1/3 of the length, either this way, that way, 1/3 point. So this is the point. So this is for the triangular loading. I'm telling you that in a nutshell. So if you have an exam, if you calculate this value, I write down the value there, and so it's like this, it will be okay. Or you can find out 1 or 2 points also, you can calculate the moment. But it is easy because it is symmetric load. So now, next we are considering what is the bending moment and shear force diagram from trapezoidal load. You see, trapezoidal load is partly, as I told you earlier, trapezoidal load is partly triangular and partly uniformly distributed. Say like this. This is your pin joint. This is your roller support. Okay, you have, say, at a distance from here to here, say here to here, it is 3 feet or 3 meter, whatever you call it, meter or feet. Here also 3, say. And this part is 4. Total span is 10 meter or feet. Okay. Now you have, say, you have an intensity there, triangular intensity, I mean. So it is 10. This is 10 kilonewton per meter or kilonewton kip per feet. So it is from here to here, it is a trapezoidal, it is constant. So here also it is 10. All 10 kip. This is 10 kilonewton per feet or meter or 10 kip per feet. Now here it is same again, it is 0 there. Now, if you have to draw a bending moment and shear force diagram, first of all you find out what is the reaction. What is the reaction? Reaction is this part is half, base is your 3, altitude is 10, plus what is this from here to here? 4. Total load is here to here is load intensity is same, 4 times 10, plus again this part is half, distance is 3, intensity at this point is maximum altitude is 10. So this is the total load. Total load, actually this is the total load. And half will here go there, half will go there. So what is the reaction? Because it is symmetric. Okay. So this is actually 30 divided by 2 40 plus 30 divided by 2. So 15 plus 15, 30 plus 40 is 70. So 70 kilonewton or 70 kip. Okay. So half will there, so 35. This is 35 kilonewton or kip. Excuse me. This is the reaction. You have to always, in bending moment and shear force diagram, always you need to, what you need to do, you need to find the reactions. That is most important. Okay? This is most important. Then you find out the shear force. Shear force, this is the key point. You can find in between also, but for our simplicity, we find out what is the shear force there. So what is the shear force? What is the total load there? This triangle. Half from here to here, distance is 3, is the triangle, area of the triangle, times 10. This is 2, this is 15. So it is shear force. This is 15 from here to here. You have got 35 there, and it is this value here, somewhere here, it is 35 minus 15, 20. So this is parabolic because it is triangular. Triangular load is triangular, shear force is parabolic. So it is going like this. Initially little flat, going slowly, then going sharp. Because intensity is getting bigger and bigger on the towards right. But at this point, the behavior of the shear force changes. Then comes the uniformly distributed. When the shear force is uniform, the shear force, when the load is uniform, the shear force is linear. So what is there? What is the middle point? From here to here, what is 2? Right? So 10 times 2 is 20, right? Half here, from here to here, distance is 2 to midpoint. So 20. So total 20, here up to here it is 20, then this load is coming, right? So it is neutralized this load, so it becomes 0. Always you see that this is the symmetric, always shear force is 0 at the midpoint for a symmetric loading. So it is straight there. It is straight this part and it will remain straight up to this point. Here also, here it is 20, it is 0. Here also it will be 20. Then after that, it will be like this, parabolic. So this is the shear force diagram, parabolic, then triangle, linear, then parabolic, because of the pattern of the load. Okay, so this is at the midpoint. At this midpoint, our bending moment will be maximum. So this is the shear force diagram. Our bending moment diagram is something like this. If you consider this one, so it will be cubic up to this point, very sharp. Then it slows down, it flattens out up to this point, then sharp. This is parabolic here, then going like this, little bit sharp. It is parabolic this part, this is cubic this part, cubic this part, this part is parabolic, little flat, not sharp. So this value, what is the moment here? What is the moment there? What is the moment here? These are the key points. We have to calculate it. What is the moment at this point? Moment is this point is area of the triangle, center of gravity is this. This is 1/3 of this is 1 meter, 1/3 of 3 is 1. And what is the load there? Half. And base is your 3. And 10 is the altitude, that is the load. So it is 15. So load is 15. So what is the moment at this point? Bending moment. Total unbalanced moment caused by the force to the left or right of the section is bending moment. And if it is like this, if you consider from left, right clockwise is positive, anti-clockwise, if you right side, anti-clockwise is positive, and from left side it is anti-clockwise is negative, and right side also it is the clockwise is negative. So just reverse. Now what is the value here? This value, how much? We can find out the moment at this point. Say if you consider it is A, this is B, MA equal to, I am consider this is the A, point A. So MA equal to your 35 times 3 minus, because this will cause a positive clockwise moment, this force. So this moment here, 35 times this distance 3, this will cause a clockwise moment. But this force is going down, it is causing a anti-clockwise. Okay? So what is this value? Is negative. Anti-clockwise is negative, right? So it is, what is the area of total force? Half base into altitude is 3 times 10, it is 15. 15 is acting 1 feet from here. We are considering the moment at this point. So 15 times 1. How much this one? 35 times 3, 105 minus 15. 105 minus 15, your is 90. This value is 90. Similarly, if you consider from right, same way. If you consider from right, clockwise is positive, anti-clockwise is positive, clockwise is negative. So it is the same value, it is 90. What is here? Moment. It is the bending moment diagram. Remember that. What is the moment at the maximum moment there? Let us calculate. Maximum moment there, this distance is from here to here, it is 5, right? 5 feet or 5 meters. Now 35 moment at midpoint is mid section or middle of the beam. M mid equal to 35 times 5. This will cause anti-clockwise, negative, so it is minus. So this value is 15. What is the distance from here to here? Here to here it is 2 plus 1, 3. This force is acting here. This distance is 2 plus 1 is 3. So 3 times 15. It is causing like this. It's negative 15 times 3. Then again, what is the, we have to consider the moment of the left and right of the section. So what is the left of this section? This section left side is this much of load only, not total load. So this much of load is how much? This trapezoidal part, this constant part is the 2 feet or 2 meter times the intensity 10, and where this acts CG, half of this. So this is half of 2 is 1. Is 1 feet or 1 meter. So it is 1. 2 times this intensity total load. This is acting at middle somewhere here. Half of 2 is 1. So that is the equation. This is the equation for moment at the midpoint. So what is the value? 30 plus 35.5 is 105, I guess. Hold on. Sorry. 35 times 5. Oh, 175. See, my table is poor now because of the calculator for many people. Earlier I can calculate everything by head, but not now. It's hard now. You become accustomed to the calculator. It's too bad. 35 times 5 is 175 minus 45. 15 times 3, 45 minus 20. So this value is moment is 175 minus 45 minus 20, 110. So this value is 110. Kilonewton meter or kip feet. This is 110, this is 90. This is the maximum moment. So this is how we calculate the moment and shear force for trapezoidal load. So this is all for today, okay? And I will be discussing some other loading couple of times, 2 or 3 times, so different conditions. After that, I will move on to truss. So I hope you understand what I am telling about. If you have any question, you can write down on the comment. If you do not understand, I try to make it simple, but I don't know. You can judge. And that is all for today. Thank you very much for attending the class. I wish you good luck and see you next time. Bye.